Hi students, welcome to HSC Chemistry and welcome to our discussion on HDPE manufacture or high density polyethylene. In the last video we had a look at how LDPE is made industrially, so in this video we're going to have a bit of a look at how high density polyethylene or HDPE is made. So the first thing to remember, or the first thing to note, is that the two processes are very, very different. Firstly, you might remember for LDPE we had very high temperatures, or moderately high temperatures, about 300 degrees Celsius, and also very high pressures of the order of 1 to 3,000 atmospheres. This one is much lower temperatures and much lower pressures. And the main reason for that is because of the presence of a catalyst. And the catalyst is going to act in the same way as the initiator did for the LDPE polymerization process. In this case, the catalyst is a Ziegler-Natta catalyst named after the two inventors, and often this is also called the Ziegler-Natta process. The key features are titanium and aluminium, and they are part of the structure of the catalyst and help to bind the carbon to create that free radical that helps the long carbon chain to grow. So here's an example where the catalyst, you can see this is the surface of the catalyst here, and right at this region where we have the titanium and the aluminium, you can see what they've done is they've again dragged off the extra bond that was between the two carbons, and they've created again this little free radical site. And that free radical site is going to bond with an electron from that pair that creates that second bond, or the second of the double bonds. And again, we're going to get another free radical end, and it'll just keep growing in the same way, the same explanation that you used for the initiator in the LDPE process. The difference this time is the catalyst is actually providing a nice surface area, large surface area, and a site for the facilitation of that polymerization process, for each new monomer unit to be added and increase the length of the chain. Now, one of the important things about this process that makes it different to the production of LDPE is the actual densities, and it's so important that we actually name them on the basis of how densely packed the chains are. You might remember that the formula for density is mass over volume. This is the symbol, the Greek letter rho, which is used to represent density, and it's found by dividing the mass of the volume. So differences in the density are a result of branching. That is, that the volume increases as we have increased branches. We just can't pack all of those atoms close enough together to get them to form a really dense substance. So the high degree of branching that we have in LDPE means that they can't pack as closely together, therefore they take up a greater volume, and as V increases, rho or density decreases, and hence these ones have a lower density than the HDPEs. So this is a kind of good little representative way of trying to identify which is which, and hopefully fairly easily you'll see lots and lots of these side branches, which means that it's much more difficult for the long chains to pack closely together. So therefore this is a low density polyethylene, or LDPE. And obviously this one here, where we've got all these chains packed very close, very tightly together, this is a much higher density, but still polyethylene, so still long chains of ethene monomers which have been added together, and just a very small number of side chains. And yes, they will exist, but certainly not in the numbers that we have for LDPE. So what's the main consequence? Well, the main consequence is in how each of these polymers is used. So a plastic like these plastic bags are very flexible and soft, and as a result, they have been produced from this low density polyethylene. As a consequence of the fact that they are very flexible and we don't have that rigidity as a consequence of the tight packing. The milk bottle, on the other hand, is an HDPE plastic. It's much more, it's hard, more rigid, and it holds its shape much better. And you can see it's actually a long straight change with minimal side chains. So this is an example of HDPE. This is the bottles. Now we'll have a look at these in a little bit more detail in the next couple of videos, but just to give you a little bit of a contrast between not only the processes used to produce LDPE and HDPE, but also the differences in the products as a result. Thanks for watching.